Welcome to Espresso and Electronics, quick sips of video wisdom. I'm your host Aneka Sunanda, and today we're going to talk about the world of multi-die design. Joining me today are two industry experts who bring wealth of knowledge from their domains. First, we have Sunil Kashid, who is the Director of SoC Design Verification at SSIR, and we have Prashant Teotia, who is the Product Engagement Director at Cadence. Welcome to the show.
Thank you, Anika.
Thank you, Anika. Pleased to be here.
So let's kick our discussion off. So my first question to you, Sunil, is that what exactly do you feel is driving the need for, multi-die designs?
Yeah, that's a great question and a good question to start with. Yeah, basically the design is following the Moore's law since ages, and then there are limitation roadblocks as the design complexity grows. Then you have the nodes shrinking in. Then again design size grows and then the nodes shrinking in, but there is a limit for this, and when it reaches to certain stage, you have three factors which are asking you to get into the better solution. One is performance, second one is the complexity, and third one is the cost. So you are growing in the complexity, um, but you need to have the same performance expectation to meet, and then it should be as if cost effective solutions also. So this has caused the die size going beyond the limit, and then it has to split somewhere. So that's the driving factor of getting design split into multiple dies.
You told us about the driving forces. Now can you tell us about what are the benefits that you see of realizing a design, in this multi-die framework or a multi-die architecture?
To continue on the previous one, as I mentioned that it needs to be a cost effective solution. The very basic driving factor of cost is the yield. Okay, as you grow in the size, monolithic designs, they become very less in the yield. The probability of failure of the die is more in as the die size increases. So yield is one of the factor. Uh, when we split the dies, it gets increases the probability of having passing dies more than the failing die. So that improvises the yield. That is the very critical and important benefit. Next is consider the era of 4 to 5 years now on, like we are procuring the IPs from the third party vendors, or in the past we used to procure the off the shelf components. It would be similar market where people can go and get the dies, bare dies in the market. Now the benefit of it is like you can realize various off the shelf component regardless of the technology node. So now the technology in such a way that you can integrate, you have a flexibility to integrate the dies of different technology node as well as the same technology node. So that's another benefit. Third, as we are cutting down onto the development cycle, you are getting the off-the-shelf component which has already proven from various aspects. So it reduces your development cycle, and so is it gives you the early hitting to the market. There are multiple benefits, but these are the more promising benefits, I would say.
So do you feel there is any performance angle to this also?
From the performance point of view is like yeah, you can define your design in a way that certain part of your design can be on the higher technology node or the efficient technology node. Certain part of the design which is probably has no performance, very high performance need can be pushed onto the technology node which is on the the older version. So you can have the mix and match of node as well, performance various technology node as well to meet your speed, performance, and the architectural requirements.
It's like you were saying, like we already have big little CPU architectures in today's SoCs, especially mobile SoCs. So I think this is a very interesting aspect, by the way, having this. Yeah.
Do you want to add something, Prashant, from the EDA point of view? I mean, definitely what Sunil is looking for is the most efficient, optimized solution, or something that can help them shrink their entire verification.
Well, naturally, because EDA is always at the forefront of design industry, right? Because the way EDA has evolved, it has evolved based on the requirement that design industry has put, because they want to do more with less, and definitely you need those simulators, those back-end tools to drive that much compute and in so much of time with the accuracy that the industry requires. And just following those aspects, even with multi-die designs, and I think Sunil has put beautifully, the challenges and the benefits of these multi-die designs. So naturally, EDA has to think through this humongous compute that is coming to the table, right? How do we tackle that with better performance, with better throughput, right? Also the accuracy. There's a lot when you drive the performance, then sometimes it's natural that the quality of what you bring on results can be compromised. So that becomes a tricky aspect for not only design but also from the ED industry side, and definitely in the industries, I would say, working very much hand in hand with the design industry in realizing these multi-die designs. And in fact, to cater to these challenges, we are now coming up with some standards as well. For example, 3D blocks. This is something new which is catering to a standard which we can streamline from IP to multi-dies and bring this multi-die design into a proper methodology and flow. So I think, yes, definitely EDA has to work together, and I'm glad to say that we are working together. Yeah.
When we move from single die to multi-die, what are the other complexities that you foresee other than performance? So we've discussed performance, but what else?
Yeah, there are many of them, but to be precise and having listing down, one is we have split the a single die into multiple die. They need to communicate. So the interaction between the die, the connectivity between the die, that's one thing. As I mentioned, like you can mix and match on the technology node, but definitely the multi-physics challenges would be there. So we need to address that. You have like some technology node dies, and then you have 5 nanometer, 2 nanometer mixing and interacting with each other and still giving the expectations right. Third one is the thermal aspect of it. So we talk about in package, system in package, where you spread the dies. It can be 2.5D implementation, or you stack the dies, 3D implementation, and it has totally a different thermal profile. So thermal management is another aspect of it. Then you have the stress and warpage in the packaging. That's a uh, uh, new thing that needs to be addressed. The fourth one is the testability of the die. So single monolithic die, we had a JTAG type controller. We supported a standard. Now there should be a similar standard, and I hope there is a similar standard, which gives the clear-cut direction of having the multi-die testability realization right. So these are certain things which comes in mind to address or to brief about the complexities.
So Sunil, you are a verification expert, right? So what keeps you awake? what do you feel are the biggest verification challenges when verifying a multi-die design?
Yeah, that's a good question. Being a verification engineer for quite some time, I do see the design complexities are increasing. So the current tool set are to an extent insufficient to handle the things. What comes in my mind is like whenever you have the design size which is growing beyond the limit, the simulation run times, the infrastructure requirement, all these things are like at times you see that okay, you run a simulation 15 days and it crashes. Okay, so that's something which needs to be addressed. So when the design size is cut into the dies, for a verification engineer, it is still a same design. There should be something which can drive that split in the design can split into the verification, have the various simulation running interacting with each other, and which gives me the the performance at max, and then the real effective utilization of the infrastructure. That's on the simulation platform. Coming to the emulation and prototyping, that's another thing. Like emulation platform has also its own limitation. So as you grow in the size, definitely yes, it needs that kind of infrastructure. The infrastructure requirement, its capability of handling the biggest design, the thermal aspect, the speed aspect, which is become a challenge in multi-die scenario. And third thing is which may not be that critical, but yeah, we use a formal verification method technology with for the monolithic, and when it comes to the multi-die, it has its own complexities, and I think we should have the formal also uh, having enhanced for supporting the multi-die.
So all in all, I hear that you want little bit of everything, right?
Yeah.
So what is your expectation for an EDA vendor? I mean, like you guys are working in collaboration, which is good, but then what's your expectation, right?
That's a very tricky question, and yeah, I would like to answer from the an engineer. I would set that expectation as to have the things realistic. Would help me out in reducing the overall project timeline. Um, yeah, those are the things I would look at out.
So, Prashant, how do you think an EDA vendor can, help a design team reduce or shrink their entire cycle, right?
Definitely, this is something that is at the forefront of ED industry as well, by the way, as I said, previously as well. And coming to particular verification aspect of it, as Sunil pointed out, few things in terms of simulation and the conventional designs itself, or when I say conventional, it's like monolithic, single die designs. They're itself getting into billions of gates count, right? You see the size, the sheer size is huge. Now consider that such designs you integrate in multi-die format, one of the which industry is doing. In fact, we have worked closely, collaborated, with industry partners where we see the design size getting sheer huge. So definitely these challenges of performance, of capacity, all these things come as real problems for which we are collaborating, working together. And for example, as Sunil brought into his point, distributed simulation. So distributed simulation is definitely one, I would say, groundbreaking. It's not something which is which cannot be thought about, but it's something which is coming at the right time with the right problem statement out there, that with their performance, with their capacity kept in mind, how can EDA help? And distributed simulation definitely does take those challenges, like from the front. And for example, for multi-die design, which is like two huge dies for an automotive design, we saw, between 3 to 5x of improvement from performance. So if they had to pull all those dice together in an integrated environment versus if they use the distributed simulation solution, we are definitely getting the performance. Similarly, from compute point of view, right? The compute is going to be a humongous, not only in terms of technical aspect, but also in terms of cost. Because here you have to procure a big memory, big compute machines if you have to integrate multiple dice together and simulate them. However, with distributed simulations, again, that is solving that problem. Now, having said that, distributed simulation is definitely something which is at the forefront of it, but then with that comes its own challenges that we have to face. For example, how they debug, how they integrate multiple interoperability of tools, right? How when you are working on one aspect of it and you move to the other tool, the other tool can pick from what one has. So all these things put together, AI ML, that's another aspect where what Sunil needs right now is how tools can help him reduce the design cycle that he said. That's his primary thing, because he's building the design for market and there is time to market. So the design complexity and size are increasing, but time to market is rather decreasing, it's reducing. So you have to do more in less, and definitely EDA has to play its role, which definitely we are working, as I said, distributed simulations, AI, machine learning, all these things put together, we are very much collaborating and working well to make progress in multi-die design.
Yeah, good point. Actually, yeah. So for the verification engineer, there are two aspects, two things that he is always worried about: having the performance, and second thing is how can I have a efficient debug capabilities. So bringing into AI into the tools interoperability between the tools, they interact, exchange the data for having the better root cause of the debug. It would be ice on the cake for verification engineer.
Correct.
Definitely. Yeah.
Finding a bug closer to tape out is going to be
Yeah.
Oh, absolutely. That's a
quite
nightmare.
costly in terms of
It's like everybody is on toes, and then you find a bug. It needs to be closed at very fast. Yeah.
Totally agree. So, Prashant, I read about the Xcelium Distributed Simulation app, right? I think it got launched, and I feel that there is a very good momentum, and your partner customers are seeing very good results. Do you want to expand a little bit on that? What is this app all about?
Yeah, sure. I think I briefly mentioned something related to this app only, in one of my previous comments. But Xcelium Distributed Simulation is a new technology that obviously has been designed keeping in mind the multi-die designs, complexity, the time that it takes, performance and all. And we have seen great results. We have worked with some key customers. We have really collaborated very closely with them for over a period of time. And we have really found that this has not only given very good numbers in terms of performance, as I said, 3 to 5x, as compared to if they would integrate multiple dies into one environment and would take that much time. It's cutting that time by 3 to 5x, which is huge and good benefit. Similarly, being distributed, as the technology says, so you are running each die simulation, keeping all in one system format. That means those dies are still in one system, simulating as one system, and yet they are simulating on parallel, on distributed machines on your farm. The load on your farm is reduced by that X, because now same simulation is getting run in distributed mode. So that definitely is a cost and compute benefit to the customers, which is again huge. But the foremost, and that I will allude it to the point that we were discussing earlier as well, is how we can do a shift left. There are a lot of areas where the distributed simulation, because it reuses, it gives you a freedom of reusing your single die test bench for multiple die or multi-die simulations for that matter. It's a huge shift left, because even before your integrated design with interposer which comes quite late into the cycle, you are able to leverage your single die test bench to form the multi-die connectivity, which tool takes care of through the virtual channel it creates, and giving you a shift left much early in your design cycle, and customers have found real bugs, real connectivity bugs of multi-dies quite early in the cycle, which otherwise they would have caught quite late. So definitely this is one technology, one app for Xcelium Distributed Simulations that Cadence has brought in, and which is yielding fantastic results for us.
So this sounds promising, but do you think there is some performance overhead or some impact? I mean, this is a question I think will be on most of the minds, right?
Right.
Because everything has to work in harmony, right?
Absolutely. So I'm glad to say sometimes few things come out to be too good to be true.
Okay.
But as I said, besides shift left, the performance is only gain. And of course, there are aspects to it. The tool is very smart in figuring out and with some inputs from the user, the tool can really give you much high performance than otherwise you would if say this technology wasn't out there. So far so good. We have seen real promising results in terms of performance. As I said, the shift left is giving. And so if you ask me, is there a price to really use it? I would say so far it's none. Of course, these are early days, but we have been in the business for long with respect to this technology. We have really worked on large designs, multi-designs. And so far, we have seen great results. And there are papers, that different partners are presenting at different forums. And I'm glad to say, so far, it's really.
And I'm sure as the designs will become more complex, the technology is also going to get evolved.
Absolutely,
right?
Yeah, this is a continuous work. We want to do more in terms of complexity, in terms of performance, in terms of what we can partner together. And as Sunil put it earlier, right, their challenge, how we can work together and mitigate those kind of challenges. Yeah.
Sounds quite promising.
Yeah.
Good.
Okay, yes. So moving ahead, what do you see, Sunil, are the future trends in this multi-die verification or multi-die designs?
Yeah, from the multi-die verification or design perspective, there are quite a few things which we need to tap on the development happening. One thing is the AI ML getting introduced and having impact on the design as well. Second thing is how good we move on the higher level of abstraction for realizing or closing the architecture as well as the design completeness. Third thing is on the post silicon, how reliable my test and testability is, how it helps me in closing the design, the silicon completeness faster. So these are few things we need to tap on for understanding the future trends of multi-die system in package.
Prashant, what do you feel in terms of EDA, verification? What are the future trends that you feel?
So I think it's actually a very good question, because the way whole industry and not only hardware but even software side, everyone is going towards AI ML. So AI ML is going to play a huge and significant role. And I'm glad that companies like Cadence are really making progress and working on really integrated tools across, not only for verification but across design and things which are the need of the hour, in terms of tackling the challenges that Sunil just mentioned. And these are real, because the design sizes, the complexities included with this generative AI chips, they are special hardware, right, for your AI ML catering, right? Similarly, if you have these multi-die designs, of course, which allude to this, you have different fields besides AI, which is like automotive for that matter. And it's all getting so much intermingled together that even EDA has to think out of the box. And definitely these challenges are going to keep us awake, are going to, keep the journey exciting and the collaborations fruitful. And I'm glad that, we have great partners like Sunil, in terms of defining and driving some of these advanced technologies. So yeah, this is how we are going to progress, and we are progressing. I think we are in the right direction.
Wonderful. So it was a pleasure having you two on the show. And I think all our listeners, will see much more benefits from the collaboration and from the insights that you two have provided them from your domains, right?
Sure, Anika. Yeah, that was indeed pleasure, being here and, talking to Sunil as well. Thank you.
Thank you, listeners, for tuning in. Keep your circuits connected and your ideas flowing until we meet next on Espresso and Electronics.